Hello everyone, welcome to our next Power Pack session of Network Theory. How are you all? खाना वगैरह खा लिया आप लोगों ने? How are you all? Okay, tell me who has already come, who has already joined. Okay, mark your attendance, guys. Mark your attendance. Tell me who has already joined. And is my voice is audible? Yes or no? Is there any problem with the voice or the video? Let me tell you. Let me tell this. Good evening, Sohini. Good evening. Voice. Good evening, Ani. Good evening, Bharat. Okay, fine. Yeah, good. So we can start our today's session. So I hope you are very well and you are doing your studies at a full pace. Okay. Even we have a festive season around in India, but we should do our studies as well, right? So let's start our today's class. So first of all, I want to discuss what we have learned in yesterday class. In yesterday class, we have learned about the superposition theorem, right? And I told you the questions which are very important for a superposition theorem because those questions can only solve using this particular theorem. Okay, so guys, if you haven't watched my yesterday video, I advise you to kindly watch it so that you can know the importance of a theorem. Okay, in that particular video, we discussed which type of question can only solve by using superposition theorem. Okay, now what is going to do in today's class? First of all, in today's class, we will discuss about the reciprocity theorem. Okay, because it was not completed in the last session, and then we will go to a Thevenin's theorem and Norton's theorem. So if you are watching me first time, my name is Ishaan Mudgal. I have 3+ years of experience. I am 5 times GATE qualified and MTech gold medalist from NIT Allahabad. These are my area of expertise. And guys, if you want a score booster series on network theory, power electronics or power system, you can follow me on a Gradeup app. The link is given in the description. You just going to click that link and need to follow me so that you can watch those videos also. Right, so let's start our today's class with the first theorem, reciprocity theorem. So for the examination, this theorem is not that much important, but its importance come out in cases of a two-port network. Okay, when we will learn the two-port network, in that case the importance of this theorem will come out. Okay, as well as sometime a tricky question can be asked in your exam that is linked with this type of question. Okay, now first of all, guys, tell all of your friends to come online and see the lecture so that they can be benefited from the lecture, as well as they can ask doubts so that we can discuss those doubts also. Okay, so let's start our today's class. So what is the reciprocity theorem? First, you need to understand where this theorem should use. This theorem can only use in passive network. This theorem can only use in passive network. What is the meaning of a passive network? What is the meaning of a passive network, guys? Passive network is the network in which you have only the passive elements like resistor, inductor and capacitor. If a network contains an active element like your dependent source, like your BJT, like your transistor, then the network is not in passive, that network becomes active. So first of all, this theorem is only applicable for the passive network. Okay, Mayur, today I will share the ID. Today I will give the ID on a chat so that you can able to copy it. Okay, but in the end of a session, I will share the ID. So first of all, the network must be passive. Next, only one independent source must be present. Only one independent source must be present. If these two conditions must be present, if these two conditions are satisfied, then only you can apply the reciprocity theorem. Okay, got this point? Yes. Ravi is saying, sir, which cannot deliver the power is passive. Yes, we can also say that passive element, but by this particular statement you can say it in that way. The element which absorb the power is known as the passive element. Okay, now let's see what is the meaning of a reciprocity theorem. So for a reciprocity theorem, you need to understand a network must be linear and passive. A network must be linear and passive. So if a network is linear and passive, and this is my source side, this is my source. Let us suppose I am applying a source voltage V, and this is my load side. This is my load side R, and the current which is flowing is I. So according to superposition theorem, if network is passive, linear, and only contain one source, it means then ratio of excitation to response will be same. Ratio of excitation to response will be same if we interchange ports. What is the meaning of this? Let us suppose I am providing a voltage V1 here, and the current I1 is coming here. Okay. Now what I want to do, I am trying to interchange the port. Network is still the same. But what I am doing, I am interchanging the input port to an output port. Now this port become the input port. Let us suppose voltage is V2, and this port become the output port. Okay, resistance is same, but because the voltage is change, so this become the current I2. So according to reciprocity theorem, the ratio of excitation to response V1 divided by I1 is equal to V2 divided by I2. But always remember, this can only be happen if a network is specifically given that it is a passive network, or they can say a network is resistive in nature. It means all the elements are the resistance. Okay, and only one source must be present outside the network. Now what is the advantage of this type of theorem? If you see in a real life, then what is the advantage of this type of theorem? In this type of theorem, you need not to have a knowledge of a elements or a configuration which is inside the element, inside a network. You just need to know that the network is passive. So if I give you one complex network and I'm just changing the voltage there, okay, then you can find out the output easily by using this particular theorem. But condition, the network must be passive. Okay guys, okay, understood this point? And reciprocity theorem follows the law of homogeneity. This is very important. Reciprocity theorem follows the law of homogeneity. Now, can anyone tell me what is the law of homogeneity? Tell me guys, can anyone tell me what is the law of homogeneity? Anyone? Hello Polly, hello everyone. And guys, share this lecture with all of your friends. I know you have a WhatsApp group in which all of you are preparing for GATE exam. So share this lecture everywhere. Okay. So Soini, the first circuit is nothing. The first circuit is just a linear and passive circuit, and I am providing a voltage V1 there such that some output is coming here I1. Now I have interchanged the input and output port. Okay. When I interchange the input and output port, I'm also changing the voltage. So according to a reciprocity theorem, if I interchange the port, even then the ratio will be same, that excitation to response. Okay. Anyone? There are many people online and no one knows about the law of homogeneity. How is it possible? Anyone? Any idea of a law of homogeneity? See beta, what is the law of homogeneity? It is one of the most powerful law that is used in your networks. Okay. Based on this law, reciprocity theorem is applicable, as well as a superposition theorem follows the law of homogeneity. What is the law of homogeneity? Let me add one blank page. And I will explain you this concept beautifully. So just wait a sec. Okay, done. So what is law of homogeneity? Very, very simple law. Law of homogeneity. Law of homogeneity tells us that if the network is passive, then output is directly proportional to, then output is directly proportional to input. Then output is directly proportional to input. This is the statement of the law of homogeneity, that if your network is passive, then the output is directly proportional to the input. Okay. For example, beta, see, I am giving you a passive network. Such that here I am applying a single input. Let us suppose I am giving V1 is equal to 4 volt. Now, by measurement from the ammeter, if I measure it from the ammeter, the current comes out to be 6 ampere. Okay. So this is given that initially when I applied the 4 volt, the current come out to be 6 ampere. Now, what is given in question? Now, V1 is changed to 12 volt. Then I need to find out what will be the current I. So in this case, I can use the law of homogeneity because the network is purely passive. So if the network is passive, the output will be directly proportional to the input. So you can see what is going to happen. Input become 3 times. 4 3 are 12. So output will also become the 3 times. So here the current becomes 6 multiplied by 3, 18 ampere. 18 ampere. Okay. Not 18 ampere. Okay, so this is the law of homogeneity, one of the powerful law. And remember one point, this law is only applicable if you have a passive network and only one source is connected. If you have two sources, then you cannot apply the law of homogeneity. If you have two sources, then you cannot apply the law of homogeneity. In case of two sources, we apply the law of linearity. In case of multiple sources, more than one source, we apply the law of linearity. Okay, good. Correct, Manoj. Absolutely correct. So, any doubt in this particular theorem? Any doubt? Okay, fine. Next. Now I need to solve this question. So, everyone try to solve this question. In this, it is given if network A and B are identical and passive. Then find I dash. Okay. Sheikh is saying, sir, please respond to message on Facebook. Okay, beta, I will see what you have sent the message. Okay. And guys, again, I'm telling you, if you want to watch a power pack session, a revision session on a network theory as well as power electronics, you can follow me on a Gradeup app. Link is given in a description. Okay, just go to and press the link, and then you can able to see the free videos there also. Okay, so try this question, everyone. How can I solve this question? Very simple question. We just discussed the reciprocity theorem. The same thing I am going to apply here. Okay, चलो ये वाला question देखते हैं जल्दी से क्या है. So in this question, what is given? Here the voltage is 1 volt. Actually, the voltage is 1 volt. So it is given if the voltage is 1 volt, current is 4 ampere. Okay, if the voltage is 1 volt, current is 4 ampere. Now what they have done, they have interchanged the port. Means this is the input port right now. Yes or no? This is the input port and this is the output port on a same network, because they are saying network A and B are identical and passive. On a same network, they have interchanged the input and output port. Now it become input, it become output. Yes or no? And for this, I need to find out the I dash. So let us suppose this is V1, this is I1, or this is I dash, this is V2. So according to reciprocity theorem, what can I write? I can write ratio of excitation to response. Excitation means input. Ratio of excitation to response. Response is I is going to be same in both the circuits. Okay. Now see here, very important point. This is a catch. If you will see, the voltage is plus minus V1. Here the polarities also change. So I have to take one polarity. Either you have to take this as a positive polarity or you have to take this as a positive polarity. So if I am taking this as a positive polarity, then 6 volt become the negative. Okay. Similarly, you have to see the direction of current. Here, the current is going outside the network. Here, the current is going outside the network. So, okay, direction of current is also okay. But the voltage, the polarity is reversed. So, I will write V1 will be how much? V1 will be 1 divided by 4 is equal to, what will be the V2? V2 will be minus 6. V2 will be minus 6. And direction of current I dash is same as that of a direction of current I. So I dash comes out to be 4 multiplied by minus 6. I dash comes out to be minus 24 ampere. Minus 24 ampere. So this is a NAT type of question. This is a NAT type of question in which you have to give the answer in a numerical form. Okay, in terms of numbers. So the answer is minus 24. But if you don't keep any care about the polarity, the answer will be 24. Okay, okay, got my point? So correct. Manoj ka answer, Kalyan ka answer, and Andy show. The answer is correct. Correct. Okay. Now try to solve this question. Very beautiful question. Very beautiful question. I am marking it as a star. Through this question, you are going to learn one beautiful concept more. Okay, when you look this question, you think that question is very lengthy or the question is very difficult. So take a few seconds, read the question, and then try to give me the answer here. And guys, if you have any doubt, you can ask in a chat box. Okay, chat box is yours. Okay, you can ask any doubt in here. Sheikh, the answer is negative. Sheikh, the answer is negative. Why? Because you can see now the voltage is minus 6. So the answer is negative. It is minus 24. Minus means actually the current will flow in a opposite direction. Okay, but I need to give answer according to a direction given in a question. That's why I have to keep minus here. So the answer is minus 24. Okay. Acha, you are asking in NAT type. Beta Sheikh, in NAT type you have to type minus 24. Because one thing you need to keep care. In any subject, no need to change the direction of current which is given in a question. You need to answer you need to provide the answer in the same direction that is given in a question, and the same thing applicable for the voltage also. Okay. Okay. So Chinni has given the answer for this question. Good Chinni. Good Chinni. Anyone else? I want answer from each one of you. I don't want that answer should be right, but I want everyone should try this question. Everyone should try this question. So in this question, two networks are given. You can see this is network 1, this is network 2. Okay. And I need to find out relation between IA and IB. Okay. Between these two. So beta, if you see this question very carefully, so you will learn one thing. You will observe one thing. The network, both of the network are same. What is going to change? The thing which is going to change is that the voltage source magnitude. Here you can see this is 12 volt. Here you can see it is 18 volt. This is 8 volt. Here you can see this is 12 volt. But one thing also changed. Here I have a voltage source and here I have a current source. But one thing I know, I can use the source transformation. So I can convert this voltage source into a current source, or I can convert this current source into a voltage source. So what I am doing, I am following one thing. I am changing the voltage source into a current source. In figure A, what I am doing, I am changing the voltage source to a current source. Okay, so if I change the voltage source to a current source using the source transformation, everybody knows now what is source transformation. Yes or no? Yes or no? Sorry. So I am taking a figure A. I am taking a figure A. Now everyone knows what is source transformation. Yes or no? Any doubt in a source transformation? So this become plus minus 12 volt 2 ohm. This become 2 ohm. What I am going to do here? What I am going to do here? I am going to convert a voltage source into a current source. I am going to convert a voltage source bacha into a current source. So when I convert it into a current source, the current source will look like this one. So it become 2 ampere. Okay. This become 6 ohm. Okay. And here the network is same. Here the network is same. Now beta, need to observe one thing very carefully. In both network, in figure A and in figure B. Now this is figure A. Now see, in both the network figure A and figure B, the figure A and figure B, you will observe that the network is identical. The configuration is identical. All the resistors are identical. What is going to change? Only voltage sources are changing, or you can say voltage source plus current source are changing. Otherwise, everything is same. Yes or no? Yes or no? Now, one method to solve this problem is that you can find out IA for this network. You can find out IB for this network, and then you can see the relation. But think about it. If you find out IA or IB according to separately, then what happens? It will take much time to solve this network, because network is not simple. Network is somewhat complex. So if you finding out IA separately, IB separately, it will consume much time. So what I am going to do here? What I am going to do? See very carefully. Here I am going to tell you the law of linearity. Here I am going to tell you one important law of linearity. So what is the law of linearity? Law of linearity is based on this particular concept. See very carefully. Very, very beautiful law. For example, I have a 3 sources connected. Okay, I have a 3 sources connected to a passive network. Okay, the network is passive, and the 3 sources are connected to it. Let's suppose this is E1, this is E2, this is E3. Okay, and a particular current is flowing here. So according to law of linearity, what happened? This current I is actually equal to A times of E1 plus B times of E2 plus C times of E3, where A, B, C are constants. This is known as the law of linearity. And one important point I want to discuss with you: law of linearity plus law of homogeneity make the superposition theorem. Okay, so this is known as the law of linearity, that a current is actually depends on each one of the input. But what is law of homogeneity? In a case of a law of homogeneity, current was only depending on one input. Okay, got my point? So here, see very carefully what is going to happen. If you take the ratio of 12 and 18, if you take a ratio, or you can see here, I can write IA. Here, see here, I can write IA is equal to 12 times of A plus 2 times of B plus 8 times of C. Why I can write this equation? Because you can see 12, 2 and 8 are the sources, are the independent sources. So I can write ABC like this, where ABC are constant. Okay. Similarly, see the IB. See, now see the IB very, very carefully. Resistance all are same. If all the resistance are same, then constant A, B, C are going to be same. Again, I am repeating myself. If all the resistance are same in both the networks, then constant A, B, C are same. So for IB, I can write this way: 18A plus 3B plus 12C. Yes or no? Now you need to compare IA and IB. So see very carefully. I will write here again. IA is equal to 12 times of A plus 2 times of B plus 8 times of C. And IB is equal to what? 18 times of A plus 3 times of B plus 12 times of C. Yes or no? So can I compare these two equations? And when you compare this equation, you will get that IB is actually 1.5 times of IA. When you compare these two equations, you will see that IB is 1.5 times of IA. If you want to check, so just check it. Multiply this equation by 1.5. 12 multiplied by 1.5 give you 18. 2 multiplied by 1.5 give you 3. 8 multiplied by 1.5 give you 12. So the answer is option C. So let me check who has given the right answer. Okay, I will take all of your doubts. Don't worry, I will take all of your doubts. So Komal, Chinni, Kittu and Andisho given the right answer. Okay. Ashish Mishra, 2 ampere. Okay. Okay, Paul is asking, sir, explain the source transformation. Okay, now Rishabh is asking, sir, how can I'm facing KVL and KCL, how to make the concept crystal clear? Beta, if you're facing a problem in KVL and KCL, go to the Gradeup app. The link you can find in the description, and there you can see the videos on KVL and KCL. There are many videos uploaded by me and other faculties also. So there you can easily learn about the KVL and KCL. Okay, now source transformation. So Polly, for the source transformation, I advise you to see my first video. But for the short form, in a short form, I can explain you what is the source transformation. So let me add a page. Okay. So what is the source transformation? According to a source, this is a source transformation. So what is the source transformation, bacha? See, if you have a voltage source, a practical voltage source, you can convert this practical voltage source into a current source. You can convert this practical voltage source into a current source like this, such that the magnitude of current source will be V divided by R, and this resistor comes in a parallel to it. Similarly, if you want to convert a current source to a voltage source, just you have to go vice versa. So a current source can be converted into a voltage source such that magnitude of voltage will be I multiplied by R. Okay. But for more information, you can follow the first video of this particular session. Okay. Chini, the another way to solve this particular question is that you need to apply both. Law of homogeneity and superposition theorem. This is the easiest way because here I explained the law of linearity. If you understand the law of linearity, so beta, you can find out the equation very easily. Okay, and just you need to compare it. Now, there is not any other method which is easier than this. For other method, you need to apply the superposition theorem, and again the question becomes so much lengthy. Okay, that's why I follow this approach, because for this you need to understand the law of linearity. So in this way, after understanding the law of linearity, I can find out equation and just need to compare these two. Okay, guys. Okay, so I hope you understand this problem, because now we are going to start the Thevenin's theorem. And Norton's theorem also. Okay, so first of all, I will give you brief introduction of Thevenin's and Norton's, and then we just jump to a question. Okay, and the question I am going to take will surprise your mind today and tomorrow. Today I will take some medium level question. Tomorrow I will take one hard level question, or you can say more than medium level question, advanced level question. Then your mind get blown out. Okay, so just I will explain you one important concept. What is the Thevenin's theorem? And then we jump to a question. So it will not take more than 5 minutes to explain the concept. So what is the Thevenin's theorem? See, Thevenin theorem is simple thing. Whenever you have a linear and bilateral element, linear and bilateral network, simple. If you have a linear and bilateral network connected to a resistor, or you can say load, for the AC circuit, this becomes the impedance. Okay. So if you have a linear and bilateral network, then I can convert this linear network just into a voltage source. I can convert this network just into a voltage source such that magnitude of voltage source is known as the Thevenin's voltage and resistance is known as the Thevenin resistance across the load. Okay, so this particular theorem is used to convert a complex network just into a single voltage source, so that if you are changing the value of RL, then you can easily calculate what will be the current across RL. Why? Because here you can see now, if I want to find out load current, the load current is just VTH divided by RTH plus RL. Otherwise, if you don't convert into Thevenin's theorem, then what happens? You need to calculate current again and again from the complex network. Now see one beautiful concept here. That if I apply the source transformation here, so see beta, what is going to change? This voltage source can change into a current source. This voltage source can change into a current source like this. like this. Okay, this become RTH, this become what? This become VTH divided by RTH, magnitude of current. So you can see जो same network है, the same network can be represented into current source also. The same network can be represented in current source also. So the direct conversion to a current source is known as the Norton's theorem. So the difference between the Norton's and Thevenin's theorem is just a source transformation. When you apply the source transformation in a Thevenin circuit, you can get a Norton circuit. Okay, so if you directly convert this circuit into a current source, it becomes the Norton's theorem, and this particular current is known as the Norton's current. This is known as the Norton's current, and beta, this particular RTH is known as the RN. So remember, for a particular network, Norton's resistance is equal to the Thevenin resistance. Okay. Now the simple point, how to find out VTH. Now the question asks how to find out the VTH. So beta, for VTH you need to remember that VTH is the open circuit voltage at load terminal. What is VTH? VTH is the open circuit voltage at load terminal. It means whatever you have a load terminal, you have to make it an open circuit. If you have a load terminal and some load is connected to it, so just open the load terminal, means remove the load and find out the open circuit voltage. That is known as the VTH. Okay. Next point, what is IN? Short circuit current at load terminal. So if you want to find out the Norton's current, you just need to short circuit the load terminal and find out the current passing through it. That will be the Norton's current. Okay, so we will go to a questions also, but the most important thing in Thevenin's and Norton's is the Thevenin resistance. So this is going to be a step to find out the Thevenin resistance. It is very, very important how to find RTH, and I am giving you guarantee that one question you are going to get in exam to find out RTH or ZTH. ZTH is also same. The step is also same. Just the difference is calculation AC becomes sometimes difficult. That's why they will never give you the complex network in case of AC, because the calculation is difficult and scientific calculator is not allowed, and virtual calculator has its limitation. So this is very good for you that they are not going to give the complex network in case of AC. But in DC they can give because calculation become easy. So see very carefully. We have two cases to find RTH. Case 1, if only independent sources are present. Case 1, if only independent sources are present. Independent source, अगर सिर्फ independent source present होंगे, the first step, deactivate all independent source. Deactivate means voltage source short circuit, current source open circuit. Simple thing. If you have only independent source, then this is a case 1 question. For this, I will deactivate all independent source, and the second step, I will find R equivalent from the terminal side. Means whatever the terminal is given, I will find out R equivalent from there. Okay. Next case is the test source method. Don't worry, we will solve question in each of these cases. Next is test source method, and it is going to be used if network contain dependent source. This particular method is going to be used if network contain dependent source. Okay, dependent source. So in this method, the first step, you need to deactivate all independent sources. Again, just independent sources need to be deactivated. Don't deactivate the dependent source. Dependent source will be remain as they are given in the network initially. Next, you need to apply the test source of either 1 volt or 1 ampere. Means after deactivating all the independent source, I will apply a test source of 1 volt or 1 ampere and then find out the RTH. If you are applying the test source of 1 volt, then RTH will be 1 divided by I, where I is the current passing through this voltage source. If you are applying a test source of 1 ampere, the RTH will be V divided by 1, where V is the voltage across this test source. Okay, so take the screenshot for this page. Take the screenshot for this page, because now we are going to jump into a question. Now we are going to jump into a question, and you are going to revise each and every topic of these theorems. Okay, and I'm going to give you one important concept that is not given in any of the book. And so this is the first question. This is the first question, guys. Try to solve this question, everyone. If you don't know the Thevenin's theorem also, then just try to solve it. Here, this is the IS. Here, this is the IS. Okay. Now, let me explain you the question, what is given in question and what they are asking. So, see very carefully. They have given this particular network. This is a dependent source. Now, tell me, which dependent source is this? I discussed this in a first class, the type of a dependent source. So guys, tell me, which dependent source is this? And bacho, don't forget to like the session. If you like the session, that is your attendance. Okay. So don't forget to like the session. Everyone should like the session. Right now, the like is come and students are more online. So I want everyone to like the session. So beta, tell me, which dependent source is given here? I told you in the first class, bacha, watch my first class on this same series. I told you in first class, first of all, you have to see inside the diamond shape. When you see inside a diamond shape, you will see this is a voltage source. If this is a voltage source, now see the magnitude. The magnitude of this source depend on a current. So this is a current control voltage source, or sometimes you can say current dependent voltage source. Both are correct. Both are correct. Okay. So first of all, you need to identify which type of source is this. Current dependent voltage source. So Sheikh is given the wrong answer. Beta Sheikh, in case of sorry. Okay, correct. Everyone is giving the right answer. Correct, bacha. Correct. Now let's solve this question. Now first of all, understood what is given in this question. What is asking in this question? They are asking voltage across terminal XY. They are asking voltage across terminal XY. What is the voltage across X? But where is the terminal XY? This is a terminal. And if you see very carefully to this terminal, what is connected? This particular voltage source is connected. This particular voltage source is connected. And I told you, what is the Thevenin's voltage? I just discussed with you, Thevenin's voltage is the open circuit voltage. Open circuit voltage at terminal. So I need to open circuit the terminal. Yes or no? I need to open circuit this terminal. Now what is the meaning of open circuit terminal? I just remove this load. I just remove this load. So here the voltage source is acting like a load because they are connected to a terminal at which I need to find out the Thevenin's voltage. So what I will do? I just remove the voltage source because it is acting like a load. Because it is acting like a load, and see very carefully, this is plus minus 0.5 is. This is 1 ohm. This is 3 ohm. Here I have a current source like this. This is 1 ampere and this is connected to a terminal Y. But I need to find out this voltage plus minus VTH. I need to find out this voltage plus minus VTH. Now beta, see very carefully. What is IS? IS is the current which is flowing from Y to X, right? But right now Y to X is open. Right now in this circuit, X and Y terminal is open. So obviously IS is 0. Yes or no? Obviously IS is 0. In open circuit, the current flowing is 0. It means the magnitude of this become how much? 0.5 multiplied by 0, because the magnitude of this voltage source depend on a current IS. So it becomes 0. What is the meaning of 0 voltage? What is the meaning of 0 voltage? It means short circuit. It means short circuit. Or I can again tell you one thing. If a voltage source has a magnitude of 0, it also means that voltage source is short circuit. Any doubt in this concept? Tell me. Any doubt in this concept? Everyone, do you understand this concept? Yes or no? Yes or no? Do you understand this concept? I want each one of you to say yes. And if you have any doubt, you can ask me again. I can again explain you this. You can ask me again. I can again explain you this. Remember one point, beta. Remember one point very, very carefully. The load terminal is XY here because you need to find out Thevenin's voltage across XY. And when you see here, that particular voltage is acting like a load. That particular voltage is acting like a load. Okay. Chinni is saying, sir, current is open circuit, voltage is short circuit. Beta, right now we are finding out VTH. Chinni, when we are finding out VTH, we just need to remove the load from the terminal. Just this thing I need to do when I'm finding out VTH. No need to do anything else. So here I need to find out VTH. So I just remove the load VS from here. So beta, now calculate the VTH. Now you will see 1 ampere flowing here, 1 ampere is going here. It will go here, but it is an open circuit. So whole 1 ampere will flow from here. Whole 1 ampere will flow, go to this short circuit, and coming back to a current source like this. Okay. It means I need to find out VTH. If I need to find out VTH, I can apply the KVL here. So see, if I apply the KVL, it will be minus VTH. No current is flowing here. So voltage drop across 1 ohm is 0. Now going further, this is plus minus. It become plus 3. Then this is a short circuit. So plus 0 equal to 0. So VTH comes out to be 3 volt. Option D. This question is just a 1 mark question, but I'm giving you guarantee most of the students will not able to solve this question because they are not thinking about the removing of voltage source. So beta, the load can be anything. It can be a load, can be a current source, load can be a voltage source, load can be a resistor. Okay, but here the load is a voltage source, so I can remove this particular voltage source from here and I can calculate this one. Okay, now let us suppose in the same question I want to find out RTH also. Okay, it is not asking in a question, but for the same question I want to find RTH also. So now if I want to find RTH, so first of all you need to see which case is given. Is this a case 1 or a case 2? Everyone should give me the answer. This is a case 1 question or a case 2 question for RTH. And guys, like the session. Still the more people are online and liking is less. Hit the like button. Yes, Jenny. That's why I told you every session is important, because in every session at least you are going to get one important topic that you didn't know earlier. So tell me, this is a case 1 or case 2? Okay, Komal has said case 2. Anyone else? Only one bachcha. Okay, क्या हो गया बच्चा आप लोगों को? देखो, in this network I have a dependent source. Yes or no? In this network I have a dependent source, and I told you if you have a dependent source, then it is a case 2 question. A case 2 question can be solved using the test source method. So what is the first step for the case 2 question? The first step, you need to deactivate the independent source. So here, first of all, this is the load. So this can be removed from here. This is a load I can remove from here. Okay, this will be an open circuit from the load side. Okay, like this. Okay, the network right now is this, because I need to remove the load right now. So the network right now is this 0.5 is 3 ohm, 1 ohm, and this will be the 1 ampere like this. This will be the 1 ampere like this. Okay, now I will see. Now I can see this is a case 2 question. For a case 2, first of all you need to deactivate the independent source. What is the independent source in whole network? The 1 ampere. The 1 ampere is independent source, so it means I need to open circuit the current source. Always remember, current source is open circuit and voltage source is short circuit. But here I have only one independent source, so I just remove the 1 ampere. Okay, like this. Now the circuit will look like this one. Now beta, listen very carefully. This is a test source method, so I need to apply one test source. Now I have two options. I can apply 1 volt, I can apply the 1 ampere. Okay, you can apply anything, the answer will be same. But right now I am going to give you one trick. Which source we should apply so that the answer will come out easily. So the trick is that if to a terminal to which you have to apply the source, a series element is connected, then you should apply the current source. Means, I will repeat myself, that अगर टर्मिनल के सीरीज में रेसिस्टर है, मींस टर्मिनल के सीरीज में कोई एलिमेंट है, then you should apply the current source. If there is some branch parallel to a terminal, apply the voltage source. So here you can see I have a element in series with a terminal, so I will apply the current source. If there would be a parallel branch, I would have applied the voltage source. So when you apply a current source, it is IS here. So you will see IS become how much? IS become 1 ampere. Okay. What I need to find out? I need to find out voltage across this. I need to find out voltage across this. Why? Because RTH will be voltage across the current source divided by magnitude of a current. Okay. So now see, this IS will go there and the same IS will go there. Okay. Now I can apply the KVL again. So apply the KVL. I am going in this direction. Okay. So you will see minus V plus IS multiplied by 1 plus IS multiplied by 3 plus 0.5 IS equal to 0. Yes or no? Yes or no? From here I can write V is equal to what? V is equal to what? Let me check if I am doing something wrong. No. 3 plus 1 4.5 IS. 3 become 4.5 IS. So RTH is what? So right now IS given is how much? 1 ampere. So it becomes 4.5 multiplied by 1 equal to 4.5 volt. So what will be RTH? RTH will be 4.5 divided by 1 equal to 4.5 ohm. RTH will be 4.5 ohm. RTH become 4.5 ohm. Okay, guys, ask me doubts. Ask me doubts. Okay, ask me doubts. So let me take your doubts. Let me take your doubts one by one. Okay, let me take your doubts one by one. Okay, so let me see. Okay, Himanshu is asking, sir, which subscription is better, Unacademy or Gradeup? Beta, you can judge by yourself. You can judge by yourself. I work in Gradeup. I will surely say Gradeup is better, but you can judge by watching the videos on YouTube. Okay, but the one thing is very important, that all of the hard work that you will do, that matters a lot. That matters a lot. The hard work that you do. Okay, if you don't do the hard work, just purchase a subscription, then you are not getting a good rank or anything else in your life. Now Bharat is asking, if load is current source, we have to open circuit. Sir, beta, if load is anything, whether it is a current source, whether it is a resistor, whether it is a voltage source, a load will always remove from the terminal so that you can find out the values according to a terminal side. Okay, fine. Now and you show, can you ask your question again? What is 0? Can you ask your question again? Good evening, Sneha. And sir, in case 2, independent source should be deactivated. Yes, Sheikh. That's why 1 ampere source is deactivated, and deactivated means it is the open circuit. Yes, fine, good. कोई भी doubt हो बच्चों पूछ लेना. If you have any doubt, you can ask. Okay. So the RTH comes out to be 4.5 ohm. And if I want to find out the Norton's current also, then the Norton's current is just VTH divided by RTH. If you have already find out the VTH and RTH, then no need to short circuit the terminal and again find out Norton's current. It will just waste your time. So VTH was how much? VTH was 3. RTH is 4.5. You can find out 2 by 3 ampere. So in this particular question, I did find out all the values. Norton's current and your whatever the values you have. Okay. Any other doubt? Anyone? If you don't have any other doubt, I can jump to a next question. So before jumping to a next question, just brief this question. Just let us brief this question. What important points you need to learn from this question? That source can be anything. Load can be anything. Load can be an active source. Load can be a resistor. Whatever be the load, you need to remove that load from a terminal so that you can find out VTH and RTH across that terminal. Second point you need to understand that cases, case 1 and case 2. Case 2 is the independent source. So if case 2 is a dependent source, test source method, in that I gave you one trick. If across the terminal you have a resistor in a series, apply the current source. If you have a parallel branch, apply the voltage source. Simple. So Abhishek is asking, what if the load is a dependent source? Beta Abhishek, this is the one thing you need to understand. Load cannot be a dependent source ever. Load cannot be a dependent source ever. Okay, because the load magnitude is going to depend on the values which is happening in the network. So you cannot make load so much dependent on other branches. Okay. Now Andrew is asking, we took IS equal to 0 at the first. How? Okay, beta, here I took IS equal to 0 because you know when I remove this voltage source, this become open circuit. Now tell me what will be the current through open circuit? Current through open circuit beta is absolutely 0. That's why IS is 0 here. Why? Because XY is open terminal. XY is open terminal and I must have open terminal XY, otherwise I can't find out the Thevenin's voltage. Okay. Now solve next question. Now everyone try to solve next question. This question is from the AC. This question is from the AC source, and you need to remember one thing. Whatever the source is given, is it DC or AC? It can be DC or AC. The procedure, the definition, everything is same in case of Thevenin Norton's and superposition theorem. Maximum power theorem will be changed. That I will discuss tomorrow. And again, tomorrow I'm going to bring a beautiful question so that you can learn new concepts. In this case, I need to find out the current passed through ZL using Thevenin's theorem. Okay. So let's take this question in homework. Okay, let's take this question in homework because I want everyone to practice some question by yourself. So let's take this question in homework. Okay, so we will solve this question in next class, but beta next class means tomorrow. Tomorrow I'm going to bring one beautiful question on a Thevenin's theorem. Okay, and you need to attend the lecture on time, correct, 9 p.m. Okay, so right now I will first solve this particular question because this is more important. Because you will see in your previous year questions, the examiner are more focused on a dependent source rather than simple independent sources. That's why I need you to solve this question first. Okay, so everyone try this question, and tomorrow I'm going to bring a very beautiful question on a Thevenin's theorem. Okay, it only open inside circuit. And sure, can you it only open? Yes, and sure. When you remove that voltage source, that become the open terminal, na? So when that become the open terminal, the current in open terminal is 0. That's why IS was 0 there. Okay, so let's solve this question. In this question, determine the Thevenin's equivalent circuit for the network of figure shown below as a function of alpha, looking into a terminal AB. Okay, so beta, one thing you need to understand very carefully. If a network doesn't contain an independent source, that network is known as the dead network. So what is the dead network? If a network does not contain an independent source. And if the network does not contain an independent source, the VTH is always going to be 0 there. VTH is always going to be 0. Why? Because while finding a VTH, I need an independent source. If there is no independent source, your network will not excite. And when your network will not excite, then you can't get a voltage across the open terminal. Right? So remember one point. Whenever you have a dead network, the VTH is going to be 0. But RTH will not equal to 0. Why? Because when you find out the RTH using the case 1 or using the case 2, when you find RTH using case 1 or using case 2, you are going to deactivate the independent source. So that's why RTH does not depend on independent source, but VTH depends on an independent source. Okay, so whenever you get a network in which there is no independent source, the VTH is going to be 0. Okay, so one point you need to remember here. Now in this circuit, I need to actually find out the Thevenin's equivalent resistance. In this circuit, I need to find out the Thevenin's equivalent resistance. Okay, so how can I find out? Simple. Just you need to see which case is this. This is a case 2. I got it that this is a case 2. I have to use the test source method. I have to use the test source method. What is the test source method? You need to apply either 1 volt source or 1 ampere source at the terminal. Okay. Now what I am thinking which source I should apply. Then I gave you trick. That if across the terminal you have a series element, apply the current source. But if across the terminal you have a parallel element, apply the voltage source. So when you apply the current source of 1 ampere, you can see 1 ampere is flowing through here. So obviously Ix become what? Ix become 1 ampere. Yes or no? Ix become 1 ampere. And when you see the magnitude here, it become alpha multiplied by 1 equal to alpha. And it is what? It is current dependent voltage source. So it become alpha. Magnitude of voltage source become alpha. Yes or no? What I need to find out? I need to find out the voltage across this particular source. So that RTH will be how much? RTH will be voltage across the source divided by magnitude of current 1. So to find out voltage across the source, which method I can use? Can you tell me which method I should use here? You can use any method. You can use the mesh analysis. You can use the nodal analysis. So right now I am using the nodal here. Right now I am using a nodal. So for nodal, let's suppose I am taking this reference as a 0. This become V1. Okay. I know Ix is flowing here, which is nothing but 1 ampere. Let us suppose here I1 is flowing. Let us suppose here I2 is flowing. Okay. Let us suppose I1 and I2 is flowing. Now see, I can apply the KCL. So if you apply the KCL, it become what? It become sum of current entering. Which current is enter? 1 ampere is enter. Is equal to sum of current leaving. Which currents are leaving? I1 and I2 are leaving. You can assume direction in any form. Okay. That will not change your answer. Just apply the KCL correctly. What is I1? I1 is V1 by 2. What is I1? I1 is V1 by 2. What is I2? I2 is this voltage minus this voltage divided by 1. V1 minus alpha divided by 1. Okay. Now while solving here, I can find out the magnitude of V1. So just solve this particular thing. You will set 2V1 minus 2 alpha. And from here you will find V1 is equal to 2 plus 2 alpha divided by 3. Yes or no? Yes or no? Simple calculation. Nothing is difficult. Simple calculation. Okay guys. Now when V1 is 2 plus 2 alpha divided by 3, I need to find what? I need to find this voltage, bacha. So what can I do? Just apply the KVL here. Nothing else. Just apply KVL here. When you apply the KVL, what you get? Minus V plus 1 multiplied by 1 plus 1 multiplied by 1 plus voltage across 2 ohm. What is voltage across 2 ohm? It is V1. So plus V1 equal to 0. So the voltage comes out to be 1 plus V1. The voltage comes out to be 1 plus 2 alpha by 3. It become 5 plus 2 alpha by 3. Yes or no? This is the voltage. Finally, RTH will be voltage divided by current is equal to 5 plus 2 alpha divided by 3. This is the answer. This is the answer. Because they told you find out in a function of alpha. So in a function of alpha, RTH is this one. RTH is this one. Okay. Now ask me your doubts. So Rishabh Pandey and Chinni, your answer is wrong, beta. Because where is the alpha? Where you forget alpha? Okay, that's why the alpha must come with the RTH. Okay. Now Sheikh, in the given question, the VTH is 0. Yes, beta. In this question, VTH is 0 because this is a dead network. And Maniclot, I am not screaming. I am just focusing on an important point. Otherwise, what happen? You guys will get sleep because you have already eaten the dinner. So you will get sleep. Okay, so that's why to increase your concentration, I am just focusing on a points. Or you can also volume down your laptop or a phone if you think that there is a large voice coming out. So any more doubt, guys? Any more doubt in this question? Anyone? So this is the basic points I discussed with you about the Thevenin and Norton's theorem. In tomorrow class, what we are going to discuss, basically we are going to discuss the maximum power theorem, because from this theorem also many questions has come in your exam and many will come in your exam. Okay. Plus, there will be a one beautiful question I am going to ask you in a Thevenin's theorem in a MSQ form, multiple select question in a MSQ form. Okay, and if you want my email ID, I am going to type the email ID in a chat box. You can copy paste that particular thing. Okay, so I have typed my email ID on a chat box. If you have any doubt, you can ask me. But beta, you need to be patient before I will give answer in just 24 hours. But you need to be patient because there are many doubts that have been coming out. Or the thing you can do, you can join our Telegram channel. The link of a Telegram channel also given in a description. You can also ask the doubts there also. Okay. Abhishek, what you are asking? How will be its network be represented? Beta, see Abhishek. If you want to represent this network in a Thevenin's theorem, this network in a Thevenin's theorem will be represent like this. This is the RTH, this is the RTH, and this is the terminal AB. Because VTH is going to be 0. Why VTH is 0? Because no independent source is given in this circuit. So VTH is equal to 0. So the network will look like this one, and RTH I have already given. Okay, so bye guys, take care. So bye guys, take care and अच्छे से पढ़ाई करना and do your homework. Okay, कल मिलते हैं सेम टाइम पर. Okay, and guys अपने ग्रुप में जो भी आप ग्रुप स्टडी कर रहे हो वहां पे लेक्चर फैला दो so that they can also be benefited from this lecture. Plus, if they ask some doubt in a live session, so you can also see the different doubt coming from different minds. Okay, so let's enjoy and we'll meet tomorrow on a same timing. Till then, bye bye, take care.